Floating 1,000,000 miles from Earth, a golden honeycomb glides through the black expanse. This is the James Webb Space Telescope, or JWST. Suspended in the silent void, JWST is not just another telescope, it's a marvel of human engineering, representing decades of collaboration, innovation, and ambition. Its journey to this distant perch was a feat in itself, requiring precision and teamwork from thousands of scientists and engineers around the globe. Launched on Christmas Day 2021, JWST is humanity's most powerful eye on the cosmos, designed to peer deeper into the universe's past than ever before. Its launch marked a new era in space exploration, as the world watched with anticipation and hope. The telescope's journey from Earth to its final orbit was a delicate ballet of technology, unfolding its massive mirrors and sunshield with flawless precision. Its 6-meter mirror, made up of 18 gold-plated segments, captures faint ancient light revealing secrets from the dawn of time. This enormous mirror is the largest ever sent into space, allowing JWST to collect more light than any previous telescope, and to see objects billions of light-years away. JWST's true power lies in its ability to see the universe in infrared, unlocking mysteries hidden behind cosmic dust. Unlike visible light telescopes, JWST can peer through thick clouds of gas and dust, unveiling stars and galaxies that have never been seen before. This capability allows scientists to study the birth of stars, the formation of planetary systems, and the evolution of galaxies across cosmic time. This unique vision has already transformed our understanding of alien worlds and the universe's structure. JWST has detected atmospheres on distant exoplanets, searched for signs of habitability, and provided breathtaking images of galaxies colliding and merging. Each new discovery brings us closer to answering some of humanity's oldest questions. Where did we come from? Are we alone? But JWST is more than a tool for discovery. It's also a planetary defender, watching for dangers in our own cosmic neighborhood. By monitoring asteroids and comets, JWST helps scientists track objects that could one day threaten our planet, providing early warnings and vital data for planetary defense. When JWST turns its gaze closer to home, the world pays attention. Its discoveries spark excitement not just in the scientific community, but among people everywhere, uniting us in wonder and curiosity about the universe we share. Its findings are not just for scientists, they're for all of us. The James Webb Space Telescope inspires a new generation to dream bigger, to ask questions, and to look up at the stars with hope and imagination. As JWST continues its mission, it reminds us that the universe is vast, mysterious, and full of possibilities waiting to be discovered. In late December 2024, astronomers using the Atlas system in Chile spotted a faint moving point of light, soon designated 2024 YR4. The object had just passed within 515,000 miles of Earth, close enough to trigger global scientific attention. Atlas, a network of robotic telescopes, is designed to find these potential threats before they find us. Data was quickly shared worldwide, launching a coordinated effort to track and analyze the object's path. 2024 YR4 is an Apollo-type near-Earth object, its orbit crossing Earth's, making future encounters possible. Estimated at 40 to 100 meters wide, it's large enough to cause regional devastation if it were to impact. Its discovery is a stark reminder: our solar system is dynamic, and vigilance is essential. Once 2024 YR4's orbit was calculated, the astronomical community quickly shifted its focus to understanding the true risk this asteroid poses to our planet. The process of risk assessment is complex, involving not just the calculation of its path, but also the analysis of its size, speed, and the many variables that could influence its journey through space. Scientists from around the world collaborated, pooling their expertise and resources to evaluate the potential threat. They ran countless simulations, each one refining our understanding of how close YR4 might come to Earth, and what the consequences could be if it were to strike. By early 2025, calculations pointed to a troubling date, December 22, 2032. On that day, there was a 2.3% chance of impact, which is considered alarmingly high for an object of this size and speed. This probability, while seemingly small, is significant in the world of planetary defense. This placed YR4 at the very top of NASA's Sentry List, a catalog of near-Earth objects that require close monitoring due to their potential to collide with our planet. The asteroid also earned a Level 3 rating on the Torino Impact Hazard Scale, a rare and serious designation that signals a real, non-negligible threat to Earth. Such a rating is enough to prompt international attention and coordinated response planning. If YR4 were to impact a populated area, the devastation could be catastrophic, obliterating an entire city in seconds with shockwaves and debris causing further destruction. If it were to strike the ocean, the resulting energy could trigger a massive tsunami, sending waves hundreds of feet high racing toward coastlines. The devastation from such an event could stretch for hundreds of miles, affecting millions of people and transforming entire regions in an instant. Current models show the potential impact corridor spanning the eastern Pacific Ocean and parts of South America, with densely populated areas at risk depending on the final trajectory. Other possible impact zones include regions in Africa and South Asia, highlighting the global nature of this threat and the need for international cooperation. These predictions are based on the best available data, but significant uncertainties remain. Factors like gravitational tugs from other planets, the Yarkovsky effect from sunlight, and even tiny changes in the asteroid's spin can subtly alter its path over time. Reducing this uncertainty is now the top priority for astronomers and planetary defense experts. Every new observation, every refined calculation, brings us closer to understanding the true risk. The more we learn about YR4's size, composition, and precise trajectory, the better prepared we'll be to respond, whether that means deflection, evacuation, or other emergency measures. Ultimately, this is about readiness, not panic. By staying informed and prepared, humanity can face even the most daunting cosmic threats with resilience and resolve. With the asteroid's path uncertain, the scientific community turned to its most powerful tool, JWST. Time was urgently allocated for 2 critical observation sessions in March and May 2025. After May, YR4 will become too faint to track from Earth until 2028, a 3-year gap of uncertainty. JWST's mid-infrared instrument MIRI will measure the asteroid's heat, providing the most accurate size estimate possible. Knowing its true size is key to assessing the threat. These brief windows may be our last chance to refine YR4's orbit before its next approach. The fate of millions could hinge on the photons JWST collects during these sessions. The responsibility is immense. The James Webb Space Telescope's unique capabilities make it absolutely indispensable for this mission. It's not just another telescope, it's a revolutionary leap in how we observe the universe, and especially how we monitor objects that could pose a threat to our planet. Ground-based telescopes, no matter how advanced, struggle with the ever-present challenge of atmospheric distortion. The Earth's atmosphere blurs and blocks much of the light, especially in the crucial infrared wavelengths that JWST is designed to detect. This means that from the ground we simply can't see the full picture. Orbiting nearly 1 million miles from Earth, JWST enjoys a pristine, stable view of the cosmos. There's no atmospheric interference, no weather, and no city lights, just the vast, uninterrupted darkness of space. This makes it perfect for observing faint, distant objects like asteroid YR4, which would otherwise be lost in the noise. As YR4 moves farther away from Earth, tracking it becomes increasingly difficult. Only JWST, with its unmatched sensitivity and precision, can follow its path and gather the data we need to understand its trajectory and potential risk. Unlike Earth-based observatories, JWST isn't limited by weather, clouds, or even the day-night cycle. It can observe at any time, continuously, providing a constant stream of data when it matters most. Radar observations from Earth won't be possible until YR4 makes a close approach in 2032, which is far too late if we want to take meaningful action or prepare for any potential threat. Only JWST can provide the precise size measurements and detailed observations needed to assess the risk right now, when early detection and accurate data are absolutely critical for planetary defense. In every sense, JWST is the right tool, in the right place, at exactly the right time to protect our planet and expand our understanding of the universe. This is planetary defense at its finest, using the most advanced technology humanity has ever built to safeguard our future and unlock the secrets of the cosmos. The discovery of YR4 triggered a well-rehearsed global protocol. NASA's warning system flagged the object, and the International Asteroid Warning Network issued a formal alert. Agencies worldwide pooled resources, tracking YR4 around the clock and cross-checking data. The JWST's involvement is a testament to international cooperation, NASA, ESA, and the Canadian Space Agency working together. Scientists from multiple countries will analyze the data, united by a shared responsibility to protect Earth. This is not about competition, but about safeguarding our planet. Decades of planning and investment have made this coordinated response possible. Our greatest asset is our ability to work together against cosmic threats. While JWST's role as planetary guardian is vital, its primary mission is to revolutionize our understanding of the universe. In just a short time, JWST has delivered data that challenges long-held theories, forcing scientists to rethink the cosmos. It has found massive, mature galaxies where only small, chaotic ones were expected, upending models of galaxy formation. Webb's infrared eyes have revealed the birthplaces of stars and planets and detected complex organic molecules, the building blocks of life. These discoveries suggest life's ingredients may be common throughout the galaxy. Some scientists warn that JWST's findings may force a fundamental revision of our cosmic story. Webb is not just a telescope, it's a catalyst for scientific revolution. The story of YR4 is not one of doom, but of human capability and foresight. Knowing about this threat years in advance is a triumph of science, giving us time to observe, understand, and act. JWST's ongoing observations are our first line of defense. If the risk is downgraded, we can breathe easy. If not, we move to mitigation, like NASA's DART mission, which proved we can nudge asteroids off course. With enough warning, a similar mission could protect us from YR4. The key is to trust the scientific process and support continued research. Our planetary shield is built from curiosity, ingenuity, and collaboration. Science is our best defense. The saga of YR4 and JWST captures our modern relationship with the universe. We are no longer passive observers, but active guardians of our destiny. JWST's dual mission, exploring the cosmos and protecting Earth, embodies our progress. The threat of an asteroid impact unites us beyond borders and politics. Scientists worldwide are working together, a model for facing humanity's greatest challenges. We should look up with awe and responsibility as custodians of a fragile world. The work of astronomers and engineers is an expression of that stewardship. Our task is to support their efforts and trust in collective human ingenuity to secure our future among the stars.